Hi everybody. So this lesson is a problem solving one about projectile motion, and I'm solving question 1 from your books, and this has to do with a cricket ball that's been thrown from a height of 1.3 meters, and it's thrown with a constant velocity of 15 meters per second, and it lands somewhere on the ground over there. So there's a whole lot of things for us to find out, and I'm going to take you through it step by step. Now, one of the key things about projectile motion and solving problems is that we keep the horizontal and vertical components quite separate. We don't mix them up. The reason is the projectile travels with constant horizontal velocity. So the formula that we use for constant velocity is V equals d over t. So these are the quantities we need to know for the horizontal components. We already know V, the constant horizontal component, but we don't know the distance it goes horizontally, neither do we know the time it takes to go horizontally. Now, looking at the vertical quantities, we know the vertical height is 1.3 meters. However, there are some hidden secret numbers that are not revealed in a question, but which we are expected to know. And one of them is the initial vertical velocity. When you just throw it, it is 0. And the other one is acceleration due to gravity is also vertical. Because it acts vertically down, we use negative 9.8 for that value. Now, the first thing we have to find out is the final velocity, vertical velocity when it hits the ground. And in order to do that, we use this equation, Vf squared equals Vi squared plus 2Ad. Okay, the only thing we don't know is Vf squared, and Vi is 0, so Vi squared is that much. So times 2 times negative 9.8 times 1.3. Okay, so you get Vf squared equals, when I put all those numbers in the calculator, 2 times 9.8 times 1.3, I get 25.48, and I get negative 25.48. And so Vf is the square root of that, and I get 5.05 meters per second. And the answer is negative because it's vertically down. It's not a decreasing number. So that's one of the things we've just found out. So I'm just going to write that. Vf is 5.05 meters per second squared. I'm just going to rub this just to make space for the rest of my working. Now the next thing we have to find is the time it takes to go from the top to the bottom, which is the same time it takes to go forwards. And we can find that using this equation, Vf equals Vi plus At. Vf we know is negative 5.05 plus 0 plus negative 9.8 times t, or your t is negative 5.05 over negative 9.8, and you end up with 0.52 seconds. Now the beauty about projectile motion is that the time is the same for both the horizontal and the vertical. So this is 0.52, this is also 0.52. Now that we know two of these three things, we can find what the range is of the horizontal distance traveled by using V equals d over t, or your distance is speed multiplied by time, and our horizontal speed is 15 and the time is 0.52. So when I do 0.52 times 15, I end up with 7.8 meters. So that's how far it goes horizontally. Now the last part of our question, and which I'll do on this side, is to find the resultant velocity. So this is how the projectile lands on the ground. When it lands on the ground, it's got two sorts of velocities. So it's got this vertical velocity, which was 5.05, and it's also got this constant horizontal velocity, which is 15 meters per second. So this black line, or the resultant velocity, we can find by using Pythagoras, and I'll just do that here. So your velocity when it lands is square root of 0.505 squared plus 15 squared, and you end up with 5.05 squared plus 15 squared. Square root of that is I get 15.83, so about 15.8 meters per second this way. Now, because it's a vector, we are often asked to calculate the angle with which it makes with the horizontal. So these two are alternate angles, so they're equal to each other. So I know this vertical and I know the horizontal, so I can get theta as tan inverse of the vertical velocity, which is 5.05 divided by the horizontal velocity, and that will give me the angle with which it hits, which it makes with the horizontal when it hits the ground. So I go shift tan and 5.05 divided by 15, and I get about 45, sorry, that's wrong, shift tan 5.05 divided by 15, and I get 18.6 degrees, so nearly 19 degrees. So that's our answer. So that's all for this lesson. Bye for now, and I hope that made sense.